So I'm going to give you a formula, which we actually just proved in the homework for 5.5b. We're going to do 5.5b today. We'll finish up 5.5 tomorrow. Thursday, yeah.
Wait, so we're going to fit and then take... Oh,
and then take a quiz on Friday.
Yeah, that was nice. I saw
yeah, you'll be all right.
I saw the middle one, and I thought we were taking the quiz the same day, and I'm like, wait, what?
Does anyone understand that? All right, here we go. F of x equals... Yeah, you were. The struggle was real.
Yeah, I was
1 plus x to the k. All right, so we just saw this in our homework, number 7. So we're going to do the linearization for things that look like this. So roots and powers. And there's a little shortcut that we can use. And I will give you this formula on a test or quiz, okay? So if you had to find the linearization for something that looks like this, f of x equals 1 plus x to the k, then the linearization, and you just did this in your homework, the linearization equals 1 plus kx. This only happens at x equals 0, okay? Now, if they give you x equals 0.1, then x equals 0 would work because that's close enough, right? Did you like that? It's close enough. All right. So let's do, I've got 5 of these. So here we go. Number 1. We'll start off easy. We'll work our way to difficult. 5 of them. All right, so number 1. All of these problems are all find the linearization, okay? So I'll just write it once, and we know that we're doing that for all of them. Find the linearization, and sometimes the linearization is not linear, which I always thought was weird. Find linearization. Okay, so let's say that f of x equals the square root of 1 plus x. Now, the first thing that you want to do for these problems is you want to get them to look like this up here in blue, right here. You want to get them in that form, so that you can actually use this little theorem that we proved a minute ago. Okay? So let's rearrange this. Let's change this a little bit. We're going to rewrite it in its power form. Do you see it already? Yeah. F of x equals 1 plus x to the 1/2. 1 plus x, right here. Oh, I'm sorry, you're right. At x equals 0. They're all going to be at x equals 0 or x equals 0.1 or whatever. Yeah. We'll just assume it's at x equals. I'm glad you said that, though, because that's important. Because if it's at x equals 1 or 2, you can't use it. You're right. Okay, so here we go. Let's do the formula. The formula here says what you're going to do is you're going to have it 1 plus k times x, and that's the linearization for it. So the linearization for this one, perfect. That's it. Yeah. 1 plus 1/2 x. If you don't like it written like that, which a lot of people that bothers them, they'd rather write it in slope-intercept form. You can rewrite it. The book will have their answer like that, though. But you can rewrite it as 1/2 x plus 1. So that's the linearization at x equals 0 for the square root of 1 plus x. Yeah, it's like a little formula. Okay, so that's a perfectly fine answer right there. Now, are they all going to be that easy? Of course not. Number 2. Here we go. Let's suppose that we have f of x this time equals 1 minus 3x squared to the 4th power. Okay? Now this is not going to actually be linear, but they're okay with that. Like the linearization of this is not linear. When you do this one and you're going to use the formula, you have to think of this right here, this 3x squared, as your x, okay? Like the whole thing. This whole thing is like your x. So this is 1 minus x to the 4th, but this 3x squared is the x instead. So when you write this in your formula, which is 1 plus kx, it's going to be 1 plus 4 times negative 3x squared. Like that. No? Okay, so the formula for the linearization is 1 plus kx. No, I'm using this shortcut right here. Yeah. I know, right? You bring the 4 down in front of it.
Do you factor the 4 in then?
Yeah, you multiply it in.
Okay.
Yep. So then you get the linearization, and I always say like linearization in quotations because it's not linear. But anyways, it's equal to 1 minus 12x squared. And that would be the answer. It is. Okay, we're going to do some harder ones, though. The next 3 get a little bit harder. Number 3. This one's actually not that bad. It's after this one. The first 3 are easy. All right, number 3. F of x equals 1 over the cube root of 1 plus x. Okay, once again, this little shortcut here is for roots and powers, okay, because roots can be written as a power, right? We can rewrite this equation or this function as f of x equals 1 plus x to the what? Anybody know? To the negative 1/3. Yeah. So the cube root is to the 1/3. You learned that in Algebra 2. And then you learned in Algebra 1 that if you can move something up, the exponent's negative. Now we can go ahead and find the linearization really quickly and easily for this. So the linearization at x equals 0 is going to be 1 minus 1/3 x. And that's the line that's going to be the approximation of it. Yeah?
And so like in problem number 2, how it was like 1 minus 3x squared to the fourth, it doesn't matter that it's minus?
Yeah, it's just it'll carry over with it.
Okay.
Yeah, so that's why I wrote the negative right here with the 3x squared.
Oh, okay.
Yep. Now, have you noticed in all of these there's always been a 1? What happens if there's not a 1 there, if it's a number, a different number, okay? So we have 2 more to do. So let's say you have f of x equals the square root of 3 plus x. Okay, that's an x. So that is no longer a 1, right? We need to have a 1 there. This only works with 1 plus x and then the power. We are, exactly. So what you want to do is you want to factor out a 3 from these, okay? So we're going to rewrite f of x as 3 times 1 plus x over 3, and then all of this is to the 1/2. Are you okay with that? Did I lose anybody on that step? So I took the 3 and I divided it out of both. I divided 3 by 3 and got 1. I divided x by 3 and got x over 3. Now, what you can do, because this is multiply, you can put the 1/2 on the 3. So 3 to the 1/2. And you can put the 1/2 on this. So 1 plus x over 3 to the 1/2. Okay, so when you write the linearization is now, this is just a constant out front. This 3 to the 1/2 is just the square root of 3. So you want to put that out front, square root of 3.
Oh, so we don't have that.
Yeah, so you just leave it as just a constant, and now we're going to do the linearization for really just for this part now. Do you see that? So this constant just moves down, becomes part of it, multiplies to it. All right, so then we bring the 1/2 down, and you get 1 plus, you can write it as 1/6 x or x over 6, whatever you want to write it as. But you get 1/2 times 1/3 is 1/6. And then the book will distribute that rad 3 in there. If you left it out, I wouldn't mark it wrong. So this would be rad 3 plus rad 3 over 6x. That would be your answer. Okay, let's do one more. Last one. Bless you. Number 5. Probably could have done more, like, because tomorrow's lesson's a little long. Probably should have done half of tomorrow's today, too. It's a block period, yeah. Okay, here we go, number 5. Suppose that f of x is now 4 plus 2x to the 5th to the 4th. Wowzers. Okay. Same idea as the last one. And this one's not going to be linear either. Anytime you have an x to the 5th or some power in here, it ends up being not linear as your linearization. Okay, so let's rewrite this. So start by factoring a 4 out from everybody. So I'm going to factor a 4 out, and I get 1 plus 1/2 or x to the 5th over 2. If you want to write it as 1/2, that's fine. And all of this is still to the fourth. Now remember, this 4 is still to the fourth power. Okay? All right, so then we can go ahead and do that 4 to the fourth, pull that out to the front, times 1 plus x to the fifth over 2, all of that to the fourth power. So you have to get it to look like this first. And now we can find the linearization.
What is 4 to the fourth power?
256. All right, L of x equals, so 4 to the fourth is 256 times, and then you simply just bring that down, right? Like it's 1 plus k times whatever that junk is there. So it's going to be 1 plus 2x to the fifth. And then you can go ahead and distribute the 256 in if you want to, or leave it. It doesn't matter. So what's 2 times 256? 512. So plus 512 x to the fifth. And there it is. That's it. No, I'd be fine either way. All right. So those are the types of problems you will get.